Hello, it's Rex from DIY Audio. I will show you the progress of the EPSUX3 project. I recently wired a second EPSUX3REGv1 combo regulator board, and I want to check the behavior in serial and parallel mode, the tracking mode. The setup presented here allows to show the parallel mode of two combo regulator board. The setup includes a bench DC power supply with two outputs, 30 volt with a 2.5 amp for each output, small 5 volt DC power supply to supply the logic circuits, a CPLD eval board with EPM570, smaller than the final project, a prototype board with a 7-segment display allowing to show output voltage or current of each output, and also to display the internal temperature of the case. Control panel board with 2 rotary encoder and push button. It's one encoder for each output, of course. Tracking mode switch allowing to set the same output voltage and current for each board with a single rotary encoder. For each channel we have 2 3mm bicolor LED. The first LED is allowed to show if I set voltage or current, red for current setting and green for voltage setting. This LED becomes red also if the internal temperature of the case is more than 70 degrees. The second LED allows to show if we are in CV or CC mode. In a CV mode, this is a normal mode for a bench power supply. The LED is green, and it becomes orange when we reach the maximum current and the PSU output work in a constant current mode. If the internal temperature of the linear regulator becomes higher than a programmed threshold, this LED becomes also red. This same thing for these two LED for the second channel. We have also 2 combo regulator board. It's version 1 of the combo regulator board with their outputs, their DC input here, and here it's their SPI link. In real world, it's the same shared SPI link with a chip select for each board. For more detail, you can also, of course, show the complete schematic that I have posted on DIY Audio forum on the main EPSUX3REGv1 project. Here, each board has been connected in parallel with a 3.5 ohm resistive load, and you have a voltmeter to show output voltage on the load and the output current. Right now, this switch allows to enable or disable completely the power supply. If I enable it, you show my previous setting was 5 volt, and for 5 volt you show the same voltage, of course, on the 7-segment display. That is it's ADC onboard read and output voltage, and that shows by the fluke. For 5 volt at the output, we can show the output current is 1.5 amp, and of course I want to try to set the voltage up to 20 volts, the maximum output voltage of this regulator board, to check if the current can reach the maximum output current that allow each board, 3 amp maximum for each board, that gave for 2 parallel boards about 6 amp. If I increase the voltage, of course I can say that the tracking mode is active right now. I increase the output voltage, and for D volt I will stop at 10 volt, okay, 10.1 volt. The output current is very near to 3 amps. Of course I don't have the exactly good value output load, so it's not exactly 3 amps for 10 volt. And normally it's the maximum output current that can deliver a single regulator board. So with 2 boards in parallel, we can really check that more than 3 amps is possible. Now I reach 5 amp for 70 volts, and I reach very soon 20 volts. Okay, for 20 volts the output current is 5.87, very near from the maximum output current. So let's say it's completely possible to use a regulator board in parallel mode and of course in serial mode. I don't show that here, but it's already tested, but much more critical, much less critical, excuse me, to work in serial mode than a parallel mode, because it's important that current sharing in each board must be good to a good thermal behavior and power dissipation in each regulator board. So you can also see on the input current of the regulator board that the consumption is not exactly the same. That is because the output impedance of the wire is important to allow a good current sharing. So in a real world, the target is to allow the free output board of the EPSUX3REGv1 design to be connected in serial or parallel mode without any ICU. It's only software in CPLD to get the good function, allowing to set voltage and current the same for each channel I want to connect in parallel, and in serial if I want also to do this. So if I check also, the resistor become very soon very hot. I can check with an infrared thermometer. The temperature, the surface temperature of the resistor is more than 100 degrees, of course. 122 degrees. I think maybe you can show the value. Okay. Of course, it's important to have a good thermal management in inside the final case, final enclosure of the power supply. So I will give you more information about all the rest of design, because it's only a small part of the design. I can set a lower output voltage, for example 12 volt, because it's very we use this setting very often. And for 12 volts the output current is 3 amp and 52, 520 milliamp. I can show you the CVCC mode detection. It's fully made by CPLD using ADC comparison. If I try to set a new current set point, a lower current set point, this LED become orange to say I set not the voltage but I set the current. So you have no difference until I reach a current setting below this value. So when I reach this value, the voltage become lower. The voltage become lower, and the second LED become also orange to say I'm in constant current mode now. I can try to set 2 amp, for example, 2 amp cover limit. Okay, 1.97 amp maximum value. So now I come back in voltage mode setting, and now if I change the voltage, you have no change, because the voltage will change only when the setting allow lower current than 2 amp. So it's okay now. For approximately for about 6 volts, the output current is 1.74 amp. But if I increase voltage, when I reach 2 amp, the current doesn't continue to increase, and the voltage is also stable. That's showing a good current and voltage regulation, and also a good detection of the CV and CC mode in this design. I can show you also the voltage and the current display. Here you have the voltage display of one board, because we are in parallel mode. If I measure voltage on this board or in this board, you have the same value, or very near value. Here 6.84 volt and here 6.86 volt, very low difference. I can try also to show you the output current measured by the CPLD and the ADC of the board, but now the displayed current is not the full output current, because the ADC measures the output current of its board. So you have about half of the current measured by the board, so the display will show only about 1 amp. We can try to... So I measure 957 milliamp. If I set the current value higher, you can see something. You have auto scale. When the output current is lower than 1 amp, you have n milliamp resolution, and when you have a current more than 1 amp, the resolution becomes 10 milliamps, allowing more dynamic measurement, more precise measurement. Okay, you can see it's about half the value indicated by the output amp meter. Okay. I hope this video will enjoy you to show how it works a little, and how the project continue to be built, and to see what we can do with that. I will give more news on the topic very soon. Bye bye!